Beautiful. And some of you came in late after I asked, and I forgot to ask again. Sign into the chat with your name and your banner ID. Make sure to send it just to me, and that way I'll know that you're you and that you're here. All right. So what we're going to do now is take X and Y and see how we can connect it with what we know about cosine and sine. So let's draw a triangle. We said that the cosine of theta was
adjacent over hypotenuse.
Yeah.
Yes. Good. And what if C is 1? What do we get?
It'd just be A.
A over.
Yeah. And let's look here. We've got A, B, C still. We said A was cosine, and A is also what value? Which one of these? X or Y?
X.
Yeah. And let's see, the sine of theta is what over what?
Opposite over hypotenuse.
Okay, let's see. That's B over C. And if C is 1, what do we get?
B.
And B, here's B. Which measurement is that? X or Y?
That one's Y.
Yeah.
Right.
Excellent. And that means that cosine is the X dimension and sine is the Y dimension of the 2 points. So if I know the coordinate on the unit circle, I know the cosine is that first coordinate and the sine is the second. So let's think of the ones we know. Let's see, we've got, let's just go back to our pretty unit circle. Where is it? There we go. So let's see. Let's find the sine and cosine of pi over 6. What is the sine of pi over 6? Sine goes with X or Y?
Y.
Yes, sine goes with Y, and sine always goes with Y. So what is the Y coordinate at pi over 6?
1/2.
And that means that the sine of every single angle, when the denominator is reduced and it's pi, and it's 6, it's going to be either positive or negative 1/2. What about, let's see, what is the cosine of pi over 4?
We're root of 2 over 2.
Square root 2 over 2.
Good. And what's its other name?
1 over square
1
root
over
3.
square root 2.
Good. I want you to know both. I really do. Okay, so because we have that connection with sine and cosine to these coordinates, and we know the coordinates all the way around this unit circle, we know the sine and the cosine all the way around the unit circle. And that's a lot to take in, but there's so much symmetry involved. So sine goes with y, cosine goes with x. Cosine is lower on the alphabet than sine, and x is lower on the alphabet than y. Sine goes with the second, cosine goes with the first. And that for pi over 6 or 30 degrees, we know that we're going up, not as far as we're going over. So that one has the y value of 1/2. For the pi over 3 or 60 degrees, we're going up more than we're going over. So the x is the 1/2. And here's the 2 pi over 3. You can see that the coordinates are the same when you adjust for the quadrant. Here's another place where we have a denominator of 3. The coordinates are the same. 1/2 square root of 3 over 2, except we are adjusting for the signs of the quadrant. Here's another place where the denominator is 3, and we still have 1/2 square root of 3 over 2, adjusting for the signs of the quadrant. And the same goes with all the others. Here we have square root of 3 over 2, 1/2 for pi over 6. The next time we have a 6, when it's reduced, is for 5 pi over 6, and the coordinates are the same. And then at 210 or 7 pi over 6, we have another time where we have a denominator of 6, and we also have root 3, 1/2 with the signs adjusted for the quadrant. And then root 3 over 2, 1/2 when the signs are adjusted for the quadrant. And the same thing with the root 2 over 2 or the 1 over square root of 2. They're always the same with the signs adjusted for the quadrant. And again, the signs are plus plus, minus plus, minus minus, plus minus. Just a sec. Sorry, I'm going to pause the video for a sec. All right. So now let's look at the other functions. So we think of tangent and cotangent as quotient functions because using sine and cosine, we take a quotient to get to them. But let's see why those are quotient functions. Let's go back to this ABC triangle and remember what was the tangent.
Opposite over adjacent.
Yes. Okay, beautiful. And let's take the sine and the cosine from before. We know that the cosine is A over C and the sine is B over C. So let's find B over C divided by A over C. Let's simplify this complex fraction and see if they are equal. So remember we talked about, I think it was last time, if you have a complex fraction, fractions within a fraction, the simplest way to simplify it or make it into a regular fraction is to multiply numerator and denominator by the least common denominator of the inside denominators. Well, these are both the same. So the least common denominator of C and C is C. So I'm going to multiply the whole top by C and the whole bottom by C. And remember I said we're going to multiply rather than divide. So, I mean divide rather than multiply. Oh, Jiminy. Okay, so we've got B over C times C, and we've got A over C times C. And what I mean by divide rather than multiply is instead of multiplying BC and then reducing by C, we're just going to think of this as the C's crossing out. And so what do we end up with?
B over A.
So no matter how we write the sine and the cosine, tangent is always going to be sine theta divided by cosine theta. And it's super easy to see that in the unit circle because sine here is B, cosine is A. If we're thinking of this triangle, C is 1. So what is the tangent using this particular triangle?
Can you say that question one more time?
Yeah, what is the tangent using this triangle, the one that is AB1?
It would still be B over A, right?
Right, it's still
over
B
A.
over A. And what is the sine using this triangle?
Square root 3 over 2.
No, just
The
A or B. Is it A or B?
for sine, it'll be B.
Yeah. And cosine?
A.
So tangent theta is sine theta over cosine theta, no matter how you measure it. And because we're taking the sine function and the cosine function and dividing them, we're calling tangent a quotient function. Because when it's using sines and cosines, we're dividing a sine and a cosine. Now let's look at how does the secant compare? Is it the reciprocal of sine or is it the reciprocal of cosine?
Cosine.
Good. And what did we say cosine was? For this unit circle.
A.
Good. So secant is 1 over A. And because we're only using one trig function to get to it, it's called a reciprocal function. Because all we're doing is taking one trig function and finding its reciprocal. Let's see, we've got one more. we've got cosecant. Cosecant is the reciprocal of,
Sine.
good.
Just to let you know, it's 11:33.
Thank you so much. Oh my gosh, you're an angel. I forget about time. Okay, let's finish up what we're doing right now, and we'll start here next time. So yes, cosecant of theta is the reciprocal of sine theta, and that means for the unit circle, it is it 1 over A?
1 over B.
1 over, good. So it is also a reciprocal function because it involves only one angle. And do you see that we can go back and forth between t's and thetas, because what we saw earlier about t's and thetas, that they're the same on the unit circle. Cotangent is also considered, it's actually considered both. So when you use the cosine over sine definition of cotangent, it is a quotient function. When you use the cotangent is 1 over tangent, it's a reciprocal. So it can go in either camp. Most of the time, people think of it as a quotient function because of the sines and cosines. Okay, oh yes. When you're looking at tangent or secant, what do tangent and secant have in common? What's in the bottom of both?
A.
It's 1 over their reciprocal.
Yeah, so it's cosine theta is in the denominator both times. And that means that tangent and secant are not defined if the cosine is 0. And now let's look at the cosecant and the cotangent. So I've got cosecant and cotangent. Here we go. And what did they both have in their denominators?
Sine.
Sine. So cosecant and cotangent are not defined when the sine is 0. And that's just really important information to have at the back of your head. And let's call it good. What do y'all, are y'all okay with calling it good?
Yeah,
Yeah.
sure.
Okay, any questions? We can have questions.
I would like to I want to say something.
Okay, please.
So you know it was just a little trick my brother came up with when he was in his college year, and
Yeah.
it's about it's the complex fraction where you have to multiply by the least common denominator, right?
Right.
So his old professor said a trick called bun to bun, like burger to burger, bun to bun. So if you multiplied A times C and B times C, so like just look, if you look at it in the way that you look at as a hamburger, you just multiply whatever's like a bun, the hamburger style.
Oh, okay, this way.
Yeah, exactly.
Yeah. You'll get the same thing. It's an extra step. But yes, absolutely. That's a lovely thing to remember. So if you multiply A and C, the two things close, and B and C, the two things farthest away, and then reduce, you'll get the same thing. The reason I like my way is, and it's not just my way. The reason I like multiplying by the least common denominator is that when you do that, you get one step. But you do have to find the least common denominator. All right. Have a wonderful, wonderful day, and keep asking questions. It helps.
Thank you, teacher.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.